Okay, so today we are going to be multiplying a polynomial by a monomial. So what that means is we're going to be multiplying one term by several terms. And to do this, because we are actually going to be distributing, we will have to use our monomial rules, our exponent rules, because when we distribute, we actually multiply. If we're just combining like terms, we only will add our coefficients. So let's start with this first one here. We are doing a monomial times a binomial. So that means two different multiplications will take place. We will do 3x times 2x. So if you struggle with this, a good thing to do is kind of write it over the side. 3x times 2x. So 3x times 2x, that would give us 3 times 2, which is 6, and x times x, which is x squared. That's where we'll use those exponent rules. When we multiply like bases, we add those exponents. Then we will also do 3x. So we have 3x times negative 5. In this case, we only would have to multiply the coefficients. 3 times negative 5 is negative 15. And then x times no x's would just be x right here. Now, some of y'all will be able to do this without having to write it over to the side, but I just wanted to show you that in case that is helpful. So 3x times 2x gives us 6x squared, and 3x times negative 5 is negative 15x. Notice these are not like terms, so we are done. We cannot combine x squared with x. Also notice that they are in descending order. We have our x squared term, then our x term. So some of the problems in the program we're using says to put your answer in standard form, so it's really important that if it's not, that you rearrange the terms before you type it in. All right, looking at the next one, we have x squared times 5x. So again, think about it the same way. There's really like a 1 right there, even though you don't see it there. So 1 times 5 gives us 5. And then x squared times x to the first would be x cubed. And think about it. If you have 1x and you distribute 2 more to it, you're going to have a total of 3 of them. And then for the next part, 1x squared times negative 6. 1 times negative 6 is negative 6, and then we would just distribute that x squared in. Again, these are not like terms because the first one's x cubed and the second one's x squared. So we do not need to do anything else. They are also written in standard form because they're in descending order. X cubed, then x squared. Remember, descending order in standard form has nothing to do with the coefficients. It's that you have your x cubes, then your x squareds, then your x's, and then your constant term. All right, so I want you to try the next one on a sheet of paper. Pause the video, and when you're done, start the video back. Okay, so let's see how we did with this one. So we have 2x times x squared. So when we do that, 2 times 1 is going to give us 2. X times x squared is x cubed. Then we have 2x times 3x. So 2 times 3 is 6. And x times x is going to give us x squared. And then we have 2x times negative 5. So 2x times negative 5 is going to give us negative 10x. Notice in this case, we had a monomial times a trinomial. So there were 3 different multiplications that take place. When we are finished, we do not have any like terms, so we are done. It is also written in standard form. You have your x cubed, your x squared, then your x's. There's no constant term in this case. All right, sometimes when we have these problems, we're going to have to distribute and combine like terms. So let's see what that looks like when that happens. So looking at this next problem here, we have this 5x squared up in the front. Guys, this 5x squared is not being multiplied by anything, so we just want to copy it down just like it is. However, then we have this negative 3x times this binomial of x plus 2. Don't forget when you distribute and it has a negative in front of it, make sure you take that negative with it. So we're going to say negative 3x times x, which will give us negative 3x squared. And then we're going to have negative 3x times positive 2. So that's going to give us negative 6x. Pay attention to your signs. If both of these are positive, but we distribute a negative in, both these should be negative now. However, in this case, once we have distributed, we can see that we have like terms. We have a negative 5x squared a positive 5x squared right here, and a negative 3x squared right there. So we now need to combine our like terms. 5 take away 3 is going to give us 2x squared, and then we still have minus 6x. Remember, we would not combine our x's with our x squareds. This is in standard form because we have it in descending order. We have the x squared and then the x term. So now what you're doing is you're putting together what you learned yesterday with what we're doing today. We're going to be distributing and then combining like terms. So we bring in that adding and subtracting polynomials. Okay, write the next one down on a sheet of paper, pause the video, try it out yourself, and when you're done, start the video back. Okay, so in this problem, we're going to multiply or distribute twice. We have this part right here in the front, this monomial times this binomial, and then this part here in the back, this monomial times this trinomial. So let's start right here, 3n times 2n. That is going to give us 6n squared, and then 3n times positive 1 is going to be plus 3n. The next one we're multiplying by negative 4, so it doesn't have a variable with it, so all that's going to happen is we're going to multiply each one of those coefficients by negative 4. So it's going to be 4 times what it was and also change all the signs. So negative 4 times positive 3 is going to be negative 12n squared. Negative 4 times negative n is going to be positive 4n. And negative 4 times positive 2 is negative 8. Now that we have distributed, we want to look and see, do we have any like terms? So I'm going to start with my highest power I see, which is n squared. That way I can put it in standard form as I go. So I can see we have a 6n squared here and a negative 12n squared here. So if we put that together, that would give us negative 6n squared. Next, I'm going to look for the n's. So if we look right here, we have this positive 3n and this positive 4n. So when we combine those, we get that is going to be plus 7n. And last but not least, down here at the end, we've got this negative 8 all by itself, just this little constant term there. So we will just tag that on the end, minus 8. So now we have simplified this expression by distributing and combining like terms, and our final answer is in standard form. Okay, so now we're going to apply this to some perimeter and area problems. So for each figure below, it says find the perimeter and area for each figure. So what you got to remember, starting with this first one, we have a rectangle. So if we want to find the area, we are good to go because we have the pieces we need. All we need to find the area of any rectangle is the length and the width. And so to start out with this first one, if I go ahead and do my area first, I've got what I need. I've got my length, I've got my width. Now remember, length and width are interchangeable, so it's probably going to be easier to find this area to put the monomial first and then the binomial. The big part you have to understand is you've got to hug that x plus 3 in parentheses. When students do it like this, 2x times x plus 3, they don't know to distribute the 2x to both parts and they get the wrong answer. So make sure anytime you're multiplying with polynomials and it's bigger than a monomial that you hug it in parentheses. And then we're going back to what we learned just a minute ago. We would just distribute. So 2x times x would give us 2x squared, and 2x times positive 3 would give us 6x. And there is the area for this figure. All right, but it also asks us to find the perimeter. The thing you have to be careful about with the perimeter is there's not just 2 sides to this, there are 4 sides. So a couple of ways you can do this. One is you could go ahead and fill out the missing sides. Obviously, if this side's x plus 3, this side's x plus 3. If this side's 2x, this side is 2x. And then we're back to a problem like we did yesterday. And so we could just stack all these up to get the perimeter. So I'm going to write perimeter right here. I'm just going to abbreviate it. We can say, okay, that's 2x, 2x, x plus 3, x plus 3. And I would highly recommend when you have those x's by themselves, put those 1s in front of them so you don't miss it. So 2 plus 2 is 4, and then 4 plus 1 is 5, plus another 1 is 6. So we'd have 6x plus 6 would be the perimeter of this rectangle. Another way that you could find the perimeter for this particular rectangle is you could have just added the 2 sides you had. So you could have been like, okay, well 2x plus x plus 3 would give me 3x plus 3. And then because you know that that's only half of it, you would just double it and say, okay, well now let's multiply that by 2. And that would give you 6x plus 6. So sometimes students will do that. They'll just add the one length and width that they have and then double it to get their perimeter. All right, so this next one's a little bit more tricky. So let's start out with the area again. To find the area, all we're going to want to do is just chop it into two rectangles. Then we can find the area of each rectangle and then add them together to get the total area. So right here for this part, 6x times 6x, that would end up giving us 6 times 6 is 36, x times x is x squared. So for this bigger square, and we could call this a square since they have equal dimensions, it would be 36x squared. However, for this part, what we would need to do is we would need to do x times 5x plus 1. Again, make sure that you hug that in parentheses. So when we distribute right here, that would give us 5x squared plus 1x. Well, the idea is we want the total area. So for this figure, to get the total area, I'm going to write it up here, we would want to add all that together. So we would have 36x squared from the first shape here, which is really a square, and then the 5x squared plus 1x from this little rectangle over to the side. And then when we combine like terms, 36 plus 5 would give us 41x squared, then plus 1x. And that would be the perimeter, the area of this figure. All right, now the perimeter is going to be a little bit more tricky. Okay, so I've seen these problems on the ACT before. So I purposely picked this problem to do with you just to help you with that. So what I'm about to show you is kind of weird, but it'll work. It's pretty easy to understand that if that's 6x right here, this would be 6x right here. And obviously, if this is 5x plus 1, this is 5x plus 1. But how do you know what this piece is and what this piece is? And how do you know that whether they're cut in half exactly or what? Well, technically, y'all, it really doesn't matter. What we can do is we can pretend like we just move these pieces. Okay, so this piece, this 5x plus 1, we're going to move it out here. And it's still going to be the exact same length because all we technically want is the perimeter. And then we're going to move this piece that's right here out to here. See how it's the exact same length? I'm just picking it up from there and picking it up from there. And then I'm going to do the same thing here. I'm going to move this piece here to here, which we also know would be 5x plus 1. And then I'm going to move this piece here to right here. All right, so why does that help me? Well, technically, if I can just make this one big rectangle by moving these pieces to get the perimeter would be the same. Then all I need to do is add this side right here. What is 6x plus 5x plus 1? And that'll give me that entire length right there. So 6x plus 5x plus 1 would be 11x plus 1. And then obviously this side here is 6x. It doesn't even matter what these pieces were because if this side is 6x, this side over here is also 6x. And then this side over here is also 11x plus 1. And obviously this side's 6x. So then all we have to do is add all those up. So we're going to stack them. And I'm going to find some room on here real quick. So I've got 6x, 6x, 11x plus 1, 11x plus 1, and we add all these together. So 6 and 6 is 12, 11 and 11 is 22, and 12 and 22 is 34x, and 1 plus 1 is 2, and you have the perimeter of this shape because all you did was take this piece right here and you moved it to there. You took this piece right here and you moved it up here, so they're still the same length, and we could figure out the perimeter. Okay, so this is going to be one of the problems that you're going to have to do in just a little bit. And you're going to type it in. So if you need to, come back and watch this video. Y'all have got the skills to do this, so you will find the area and the perimeter of the figure. And I would draw them on your paper and draw them separately, so that way you kind of get the idea without having to, do the area and then the perimeter on the same figure. All right, last problem for today. The perimeter of the rectangle is 8x plus 8. What is the length of the missing side? All right, so guys, what we know again, if this is a rectangle, we know that if this is 3x plus 1 right here, that this side over here is also going to be 3x plus 1. What we're missing is these sides right here, which is why there's like a little box there. That's what it wants you to find. So let's add the two sides that we have. If we have 3x plus 1 plus 3x plus 1, that adds to give us 6x plus 2. If we know that the total perimeter is 8x plus 8, we have to ask ourselves, what piece are we missing? How much are we missing to add up to that 8x plus 8? So one way you could do it is you can just take the 8x plus 8 and then subtract these two lengths from it. So subtract 6x, subtract 2. Make sure you subtract both of them. And we can see that we still need 2x plus 6. Okay, but the deal is we have to remember that this 2x plus 6 is both of these sides. That's the two widths. So then you've got to half that to get the one width that we're missing. So if it's both of these added 2x plus 6, if we divide that by 2, kind of think about that, then that would give us x plus 3. And what I would do is I would make sure, once you figure that out, that all of these, if we did add them up, would add back to 8x plus 8. So let's check that out real quick. So if we have x plus 3x plus x plus 3x, yes, that adds to 8x. And then 3 plus 1 plus 3 plus 1 does add to 8. You just kind of make sure that it works out. Of course, this isn't the only way to do this problem. This is just one way to do it. All right, good luck with today's lesson.